What happens when we simplify expressions with exponents? Especially when we are dealing with laws of exponents, right? Students often struggle when it comes to laws of exponents. So, we'll get into its domain in here that very first, what are the difficulties they usually face? Second, why they make mistakes at the time of applications of these laws? And third, what are the solutions to get rid of these mistakes and having command on these laws? Hello everyone. So today I have come up with one of the complex yet interesting topic which is laws of exponents. These problems occur due to lack of conceptual understanding. They are having confusion with different types of exponents due to lack of practice, or they are simply memorizing the laws without applying it in the questions. And very important, they are incorrectly interpreting symbols and parentheses. It happens because they are simply moving from arithmetic to algebra. So, to address these challenges, I am here to discuss three of the most important laws of exponents, which are power of power rules, second, power of quotient rule, and third, power of product rule. So before starting, let's have a quick understanding of laws. So what are laws? The laws are the principles. Okay, so those principles are the fundamental rules which helps us in guiding how things generally work in nature. Okay, for instance, if I take a person, that person is all alone playing with the ball, throwing up and down. So what kind of scenario you will be having in your mind? There are two perspectives of seeing the scenario. First is this. So, the first perspective of seeing this scenario is this one, and the second perspective of seeing this scenario is this. So, when you're throwing the ball up, it is coming down. So, there is a law behind the ball when it is coming down. So let's come back to the laws of exponents. So here we are having the expression which is 4 raised to the power 3 raised to the power 2. So in this expression, if we start solving this, so what will be the way of solving it? 4 raised to the power 3. So first of all, we'll solve this one. 4 raised to the power 3. So 4 raised to the power 3 will be 4 is multiplied by itself 3 times. So 4 4 16, 16 4s 64. We will write, and if we simplify this further, so the value will be 64 raised to the power 2. This will be 4096. And what is the another way of solving this expression? Let's see. If I write it as 4 raised to the power 3 raised to the power 2, this can be also simplified as 4 raised to the power 3 raised to the power 2. We can multiply these exponents. 3 multiplied by 2. So we can write it as 4 raised to the power 3 multiplied by 2. 3 2s. 3 2s 6. And if we simplify this 4 raised to the power 6, this will be also equals to 4096. So what we have seen here, whenever we are having these kind of expressions like a non-zero number has the exponent which is 1 on the other, so we can write them as in general a raised to the power m raised to the power n. So this can be equals to a raised to the power, these exponents will be multiplied, m into n. So this is called law of exponent, which is known as power of power rule. Power of power rule. Why we are saying this? Because whenever there is a non-zero number having exponents 1 on the other, these exponents will be multiplied with each other. Okay. Now I am going to show you one another expression which looks alike, which is 4 raised to the power 3 raised to the power 2. So what do you think? These two expressions are same? This one and this one, they are same? No, they are not same. Let's see how they are not same. 4 raised to the power 3 raised to the power 2. If we want to simplify this, how will we do this? 4 raised to the power. First of all, we'll simplify this one, 3 raised to the power 2. And 3 raised to the power 2 says that 3 is multiplied by itself 2 times. So 3 3 is 9. So if we simplify this further, 4 raised to the power 9. So as you can see, this is 4 raised to the power 6 and this is 4 raised to the power 9. So obviously these value will not be equal. Anywhere these will be different. So what we have seen here, if we write it 4 raised to the power 3 raised to the power 2 and there is another expression which is 4 raised to the power 3 raised to the power 2. If you think they both are equal, no, they are not equals to each other. They are different. They are way too different. Why? You must have heard a word in English. If I interconnect these maths into English, so you must have heard that word homonyms. What does it mean? Homonyms stands for those words which sounds alike and they spell alike. So we can say these two expressions sounds alike. If you read this 4 raised to the power 3 raised to the power 2, and how we will read this 4 raised to the power 2, 4 raised to the power 3 raised to the power 2. So they sounds alike and they spell alike. So there is no spelling, but they look alike. They obviously they look alike, but there's a minor difference of this bracket, but the meaning is different. The method of solving these expressions is different. So they are obviously they are not same, they are way too different. So these kind of expression, whenever a non-zero number having exponents one on the other and there is a bracket, so this leads to application of laws of exponents. Whereas if you see this kind of expression where there is no bracket at all, so this is not an application of laws of exponent, whereas this simply leads to application of exponent. Okay, so why I have written this second expression together with this first expression? Because initially I have discussed one point where the students make mistake. The very important point is student wrongly interpret the laws. So this is the wrongly interpreted of the expression. They think that they both are same, but they are not same. There is a difference of bracket. So whenever you see the bracket, only then you can use the laws of exponent. And if you see this one without the bracket, you can simplify in this way, 4 raised to the power 9. Okay, now let's come to the another law of exponent. Now let's get into the second law of exponent, which is power of quotient rule. So here I am having the expression which is 2 upon 3 raised to the power 3. So what is the quotient here? The quotient is 2 upon 3. And what is the exponent here? The exponent is 3. So if we simplify this expression, we will get 2 raised to the power 3 upon 3 raised to the power 3. And if we simplify this further, we will get 2 raised to the power 3. That means 2 is multiplied by itself 3 times. So 2 2's 4 2's 8. And 3 raised to the power 3 says that 3 is multiplied by itself 3 times. So 3 3 is 9, 3 is 27. So we will get 8 upon 27. So when we are having this kind of expression 2 upon 3 raised to the power 3, it says that the exponent is on the numerator and the denominator as well. So there we have evaluated a upon 27. So there is nothing common between 8 and 27. So this is the final answer. So whenever we are having this kind of expression, when the whole quotient is having the exponent, so we can generate a law of exponent, which is, in general, the quotient will be written as a upon b and the exponent will be written as m. So a upon b raised to the power m. So we will write it as a raised to the power m upon b raised to the power m. So this exponent will be on the numerator and on the denominator as well. So this law of exponent is known as power of quotient rule. Okay. Now I'm going to write another expression which looks alike, which is 2 upon 3 raised to the power 3. Now, what is the big difference between these two expressions? However, they look alike, but there is a big difference. What is that? So, if we have written this 2 raised to the power 3 upon 3. So, we will consider it as the exponent of 2 is 3, whereas the exponent of 3 is 1. So, if we simplify this further, we will get 2 raised to the power 3, which is 8, and 3 raised to the power 1, which is 3. So after simplifying this 2 upon 3 raised to the power 3, we will get 8 upon 3, which is completely not equals to 8 upon 27. Okay, so if I'm going to write these expressions as 2 upon 3 whole raised to the power 3 and 2 upon 3 raised to the power 3. So this sound alike, they look alike, but they are way too different. They are not equals to each other. This is application of laws of exponent, whereas this is the application of exponent. All right, I'm going to write it. Application of laws of exponents. In short, I'm writing exponent, and this leads to application of exponent. Simply exponent. Okay, there is no law behind this. This will be considered as 2 raised to the power 3 and 3 raised to the power 1. Okay, now what is the reason behind it? Why I have written this expression? Because again I am saying this, initially I have discussed the point, wrongly interpreted of the laws. So this one is the wrongly interpretation of this law. We think that they both are equal, but they are not. There is a difference of bracket. Okay, so once there is a bracket, you can apply the law of exponent, whereas there is no bracket at all, you can simplify this in general way. 2 raised to the power 3, that is 8 and upon 3. Okay, now let's come to the third law of exponent, which is power of product rule. Now next law of exponent is power of product rule. So here I am having an expression which is 2 raised to the power 2 multiplied by 3 raised to the power 2. So what is the similarity here? As we can see, there are two bases, which is 2 and 3, and their exponent is same, which is 2. So in this way we can write this expression as 2 multiplied by 3 whole raised to the power 2. Why we have written this? Because their exponent is same. So that's why we have written 2 multiplied by 3 raised to the power 2. And if we want to simplify this, how will we write this? 2 multiplied by 3. First of all, we'll simplify this one, this product. 2 multiplied by 3. So this product will be 6 and whole raised to the power 2. And 6 raised to the power 2 is 6 36, because 6 has been multiplied by itself 2 times. Okay, so whenever we see any expression where the bases are different and their exponent is same, so we can generate a law of exponent in general, which is, let's say, a raised to the power m multiplied by b raised to the power m. So these bases are different, but their exponent is same. So this can be equals to, first we'll find the product of these bases, which is a multiplied by b, and whole raised to the power m. Since they both are equals to each other, so we can also write it as a multiplied by b raised to the power m. This will be equals to a raised to the power m multiplied by b raised to the power m. So they both are equals to each other. So this law of exponent is known as power of product rule. Okay, now I'm going to write another expression which is same, sometimes looks alike. So if I write it as 2 multiplied by 3 raised to the power 2. So do not ever think that 2 multiplied by 3 raised to the power 2 is same as 2 multiplied by 3 whole raised to the power 2. No, these two are not same, they are different. So if we want to simplify this expression says that the exponent of 2 is 1, whereas the exponent of 3 is 2. So first of all, we simplify this. The 2 raised to the power 1 will be as it is 2, and 3 raised to the power 2 will be 3 3 is 9, and 9 2 is 18. So these two expressions are not same. We cannot write it as 2 multiplied by 3 raised to the power 2 will not be equals to 2 multiplied by 3 raised to the power 2, because here this is the application of law of exponent, where this is the application of exponent, so they are not equals to each other. So this expression is a wrongly interpreted of law. Okay, so now we have discussed three very important law of exponents. So, what is the main purpose of discussing these laws of exponents? The very first point is the students are not having the clear understanding of the concept. Second, they are not practicing the laws, whereas they are simply memorizing these and they are thinking they will directly apply these laws in the questions, which is wrong. Okay, so all you need to have a clear understanding of this concept, which leads to practice, a lot of practice. Then, after you will see the results. Okay, and you may be having the wrong interpretation of these expressions. So when you will come to know that you are making mistake, when you will be doing the practice. Practice means practice, you have to do that anyhow. Okay, so that time you will be analyze, you will be having the clear scenario in your mind that this is the correct expression and there is the wrong interpretation of the law. Okay, so hope you have understood. Keep learning, keep growing. See you in the next video. Bye.